Continuous delivery is super important for our users and for our engineers. We need to get out our changes to production in front of our users as soon as possible to provide them an ever-improving experience and new features. And now the industry, as well as organizations, have realized if they don't implement continuous delivery and make moves towards continuous delivery, they're going to be left behind and not be able to keep up with competition or fix the bugs that their users reported in a timely manner. Yahoo realized this very early on. They realized in order to be successful, they needed continuous delivery pipelines, and they needed to automate as much as possible so developers could focus on the source code, writing new bug fixes or new features, and test code, improving the quality, not releases and deployments and orchestration. Today, I'm going to talk about how Yahoo centralized structure, specifically infrastructure and tools, and how it helped developers with CI and CD, and how it helped them get up and running with a pipeline so they could concentrate on the product. My name's Neil Manvar. I currently serve as a solutions architect for Sauce Labs, and what I want to do is show everyone how to deliver quality code frequently. What I mean by quality code is it's tested using automation. What I mean by deliver frequently is continuous delivery. Another big piece of continuous delivery is, we're all making the move to Agile, and we understand Agile is the right way to develop and deliver software. In order to do Agile properly, you need to push out iterative changes frequently to the user and learn from their experiences. In order to do that, you need a continuous delivery pipeline. So real quick, before we move on, I just want to do a quick agenda. So what we're going to talk about first is how Yahoo used to operate, how it was a decentralized structure that required you to create jobs and pipelines from scratch. Just go into Jenkins, do everything, set up the slaves, and so on, and what impact it had. Also, real quick, my previous experience was I was a front-end developer and quality engineer at Yahoo, so I'm going to be pulling a lot of experiences from there. After I discuss the decentralized structure, we're going to discuss the impact it had and the problems it presented to the developers and the organization. Once we discuss that, we're going to talk about solutions, specifically what Yahoo did to make it easier for teams and developers to get up and running with the pipeline and to focus on product development. Once we do that, we're going to look at some of the features that some of the centralized infrastructure and tools had, specifically centralizing the Jenkins infrastructure and creating a layer called Screwdriver, which leveraged Jenkins and created a pipeline. Once we do that, we'll talk about the impacts and benefits that it had to the organization, as well as complications with the centralized structure and pros and cons. So, when I first joined Yahoo, specifically Yahoo Mail, we had our own build infrastructure. We had our own Jenkins instance, our own Jenkins slave, and so on. Now, let's say my product manager came up to me and said, hey, we're going to develop a new options menu, so can you create the new pipeline for that? Because we want to be able to deliver independently of the main mail product and have continuous deployment. So that was really nice. We all want continuous delivery and deployment, and we also want the product done. But how do we focus our time? Do we focus our time on the pipeline or the aggressive deadline that says we have to get this product done by this time? When it was decentralized, I had to create all of the Jenkins jobs. So I'd go there first, set up the job, set up the slaves, and so on. What happened is now, I could set up a really advanced continuous deployment pipeline, but now I only set it up for one product inside of Yahoo Mail. Then you have Yahoo Fantasy or any other property. They have their own Jenkins infrastructure, their own pipelines, and so on. Now what happened is teams that didn't have expertise in continuous integration and delivery had really weak pipelines. And teams that were really advanced had great pipelines and were very close to continuous delivery and deployment. Now, what also happened is since everyone is doing everything separately, some teams were doing things with the best practices in mind. Some were not. And I can give one example of myself not doing something. I attaching slaves to my Jenkins masters and hard coding global dependencies and global configurations. But now if this slave went down, my entire pipeline went down. I also had no backup for my slave. So this presented a very big problem, and frequently this did happen. Something went wrong, and now my pipeline and my delivery schedule is now compromised because I was not following best practices and operating inside a container or a VM or so on. The real result of all of this was that we had many change-related outages. We'd do some undocumented change or documented change. It would make it through the pipeline, which should have said that something's wrong here, can't push this to production, and it would get into production. And we called these CROs, change-related outages. And another best practice that I didn't follow that resulted possibly in a few change-related outages is you go to configure your Jenkins job, and you say execute shell, and I had a big fat shell script in that Jenkins job, and I couldn't keep track of it. I'd change it, something happens, it's not in source control, there's no way to know what caused what. And always the source code was constantly changing as well. So let's go through the process of creating a pipeline in the decentralized times. First, I create my new repository, GitHub. After that, since my team owns the entire Jenkins infrastructure as well as the product, I have to obtain the hardware. If I need new build slaves, I have to go request for that and acquire it. Once I get the build slaves or the hardware for that, I then set up the slaves. And as I mentioned, I wasn't following best practices before and just SSHing into there, installing whatever I need, and it wasn't part of my build. Therefore, my build or job or my pipeline was not atomic and autonomous. Once I get the slave set up, I go in there, write up all my build and deployment scripts, test it out, see if it works, and then start setting up my pipeline, my Jenkins jobs. At the end, I test my pipeline, see if I can push a change to delivery. Now, since I had to do all of this from scratch in order to get a new product pushed anywhere, I'm most likely just going to do the most minimal pipeline and the most minimal work up front, and then possibly focus on improving it later. Later never comes, and improvement never comes either. So we're stuck with a weak, stale pipeline for the entire time. So really, there was heavy investment before product development could start. I had to lay out the entire pipeline, architect it, implement it, so on, which resulted in a weak pipeline or a minimal pipeline, as I explained that we had to get product development started, and the pipeline had to be laid out up front. So let's create a minimal pipeline, move on to product development, and focus on the pipeline later. Also, since I was setting this up and not everyone else could contribute or anything like that, and only I knew how the pipeline worked, the pipeline stayed stagnant. It stayed stale. Therefore, new technologies were not introduced very often, unless someone really was ambitious. In addition to that, every time a new product came about that required a new pipeline, I saw myself going to Jenkins, assembling a pipeline, writing build scripts. I found myself reinventing the wheel. This was, a lot of time was spent setting up pipelines where I should have created some type of automated process to do this. But if I myself created an automated process to do that, that would only impact Yahoo Mail. What all the engineers wanted was a continuous deployment pipeline. Also, since we're working on a minimal and weak pipeline, CD was not encouraged because we were barely comfortable with what we had in our current pipelines. So why would we continuously move to continuous delivery if we weren't confident in our pipelines? So really, what the engineers wanted was an easy way to create a reliable and strong pipeline up front without heavy investment. Also, as I mentioned, I wasn't following best practices before, and I myself was not a Jenkins expert, nor am I now. But we were having problems with having a stable Jenkins instance. Our Jenkins was overloaded, we had too many jobs running, and it would periodically restart itself. This was a showstopper for a continuous delivery or deployment. We couldn't have a Jenkins instance that randomly restarts. Developers and engineers would lose faith in the pipeline. What engineers also wanted is they wanted to be able to set up their entire pipeline from scratch and have clean environments, build slaves, containers, and so on. As I said, I wasn't following best practices, installed a bunch of global dependencies that the build scripts relied on. Therefore, if the slave went down, the pipeline went down. This cannot happen in a continuous delivery or deployment environment. You must have all your setup as part of your job or your build scripts. And therefore, if you have a clean build slave, you can get everything installed on there that you need, run through the build, and move on. Also, what developers wanted is a way to create an easy pipeline, not just create individual jobs and then have to hook them up and interact with Jenkins in the raw form. Also, since we were responsible for spinning up the pipeline and doing everything in Jenkins, as I said, achieving continuous delivery was tough. And it'd be nice if we could say, hey, here's what I want the pipeline to do. Here's my product. Please make the continuous delivery pipeline. So the first solution was to centralize all the Jenkins instances. Yahoo Mail had its own separate Jenkins, Fantasy, Sports, and so on. Now, if we can get everyone on the same Jenkins instance and solve the problems for everyone, the scaling problems, also the best practices problems and all of that, at least we have some control over everything. So what happened is this DPS team was created, Digital Platform Services, which were responsible for all developer tools, including Jenkins. So what they did is they spun up their own Jenkins instance and made sure it was scale, also encouraged best practices, documented all this, and there were initiatives put in place for everyone to decommission their own Jenkins instance, so let's say Yahoo Mail, and move towards the centralized instance. What this also helped with is enforcing security and certain standards. Everything must go through this build system. So you don't have your own way to production from undocumented Jenkins slaves, Jenkins instances, and so on. Everything must go through here. Everything must be blessed in a certain way, and so forth. Also, now, since engineers didn't have to maintain the Jenkins infrastructure directly, or more specifically product engineers, they could focus on the product. They didn't have to worry about Jenkins going down and restarting itself or anything else, or someone else setting up the Jenkins slave incorrectly. And as I defined, there were initiatives put into place to migrate to the central instance. Now that we're centralized, we needed a tool to create pipelines with ease. So far, all that's happened is I moved my Jenkins jobs from this instance to a centralized instance. Cool. Now I don't have to manage my Jenkins infrastructure. But still, that doesn't exactly move me closer to continuous delivery. So what happened next is the DPS team created this product or service called Screwdriver. I like to call it my best friend when I was at Yahoo. But what this did is I was able to essentially describe a pipeline in code, throw it into Screwdriver, and out comes an entire Jenkins pipeline. So what Screwdriver was doing is it was hitting the Jenkins APIs, creating jobs, configuring jobs, and out would come a pipeline. So essentially, this served as a layer on top of Jenkins, where a developer could register their Git repository, their project, and give it a JSON file where they say, hey, I want job 1 to do this, job 2 to do this, and if job 2 succeeds, I want job 3 to run. So what this did is engineers didn't need to know and have Jenkins expertise. They could just describe their pipeline in code. It would go into source control, and out would come a pipeline. Developers would stay where they're comfortable, inside the text editor and committing code, inside source control. And the pipeline would be auto-generated and auto-maintained. And I'm going to show diagrams of this and go into this in depth. But before I go into that, I want to describe how it was to create a pipeline using Screwdriver as opposed to the decentralized times. So now, first step, same. I create my repository, right? You need a repository to write code. Got to put it somewhere. Got to keep track of it. After that, I would create my screwdriver job. I would tell my screwdriver job, here's my new product, mail options, and here's the Git repository for it. Then I would assemble a config.json. This config.json is what I was talking about earlier, where I described my pipeline. And I'm going to show you an example of a config.json. But I would say I want a pull request build that runs my unit tests and my functional tests. Oh, I want a QA build, which, on merge to master, it will run tests and then deploy to my QA environment. And I want a production build that pushes a production every day at 3 o'clock. So after that would get fed into Screwdriver, I would have a pipeline. I would just test my pipeline and then go for it. Screwdriver also provided a bunch of other benefits that were Yahoo specific that I will go into earlier. And some of you might be asking, oh, this sounds like Jenkins pipeline, Oh, you can just write your build code put your build stuff in source control, and then that gets executed in Jenkins or configured in Jenkins. Yeah, it's kind of like that, but what Yahoo and DPS were able to do with the config.json is have entire control over it. I'll give an example later where you could just say pull request build, and I want it to run my unit tests, and you wouldn't have to interact with webhooks saying GitHub, please hook into CI and run my build whenever I have a pull request or any of that. This was all out-of-the-box functionality. So really, this is what Screwdriver looked like under the hood. This is obviously a very simplified diagram, but you have your config.json. It feeds into Screwdriver, which then creates the Jenkins jobs. You also have a front-end interface to look over and monitor all the Jenkins jobs, what succeeded, also a pipeline view, and so on. So it was a service on top of Jenkins, as well as a front-end interface. So developers really didn't ever need to go into a Jenkins job unless it failed and they wanted to look at the workspace or artifacts or so on. Everything was in Screwdriver. So config.json goes into Screwdriver. Now you have a pipeline. You can also say in your config.json, when job 1 passes, I want job 2 to trigger, or I want job 3 to trigger only at 3 p.m. or so on. Now, what would happen when you run a job via Screwdriver on the centralized Jenkins infrastructure is that job would create a container, or would run in a container, which was defined in your config.json in your repository, and then it would install any dependencies it need, and after that, the container was nuked. This left the build slave clean. Before, I was operating raw on my build slave and polluting it. Now here, on the centralized infrastructure, I'm operating on this container where I can do whatever I want and then destroy it without having any impact to anything else. Now this is following best practices. Now it didn't matter if a build slave went down or so forth. I had my build steps all in code, and it was all reproducible. All I needed was to have a container running and do things in it. It would install the dependencies, run the unit tests, functional tests, and so forth. So centralizing allowed essentially to scale best practices all throughout the entire Yahoo organization, not only in one team. So now we talked about Screwdriver under the hood. I just want to take a look at that config.json because we've been talking quite a bit about it. So here, this is pseudocode. It looked a little bit more lengthy than this. But this is kind of a pseudocode of the pipeline we had at Yahoo Mail. The first piece, the pull request build, what that's saying is please run my unit tests, my code coverage check, and my functional tests whenever a pull request is issued to my repository. Now, if I was to set up a pull request build from scratch, and I mentioned this earlier, I would have to go to my GitHub repository, set up my webhook. I would have to go to CI, Jenkins, and set the pull request build stuff up there as well, right? Now, in Screwdriver, if I just say pull request build this, I have all the out-of-the-box functionality. It'll automatically run my unit test code coverage and functional tests and set up webhooks, set up my Jenkins jobs such that anytime a pull request is issued to my branch, this will happen on the code on the branch that was requested to be merged in. So for example, as a developer, if I create a new bug fix, I submit a pull request. That pull request then triggers a build, which will run through the unit test. Now, if I submitted the bug fix and didn't write any unit tests, or submitted the new feature and didn't write any unit tests, the code coverage would catch that. This was one of the key features of making sure no untested code would make it into the code base. We enforce code coverage at the pull request level. So as a developer, I write a bunch of JavaScript, I submit a pull request. Unit tests might pass, but then I get the code coverage numbers, and unit test code coverage drop from 80% to 75%. It'll fail to build and give the feedback on the pull request saying, hey man, you didn't write any unit tests for your source code. You must maintain 80% code coverage in order to get this build to succeed and then run functional tests, or move on to the next step, which is running functional tests, right? This was great because sometimes, it comes time to release and you realize, oh, we only have 10% code coverage. Oh God. Then you get into a unit testing sprint and it's, you guys should have thought about quality upfront and route unit tests as you're going along. And this is what enforced it. There was no way to get untested code into the master branch. Therefore, we didn't have any legacy code, because legacy code translates into unmaintained and untested code. The second, so if any of these steps fail, it says notify author. So I submitted the pull request, I didn't write any unit tests for it. It sends me an email and says, hey, your pull request build failed due to you not writing unit tests. Another key piece is running the functional tests as part of the pull request build. Now we know that this is quality code. I defined quality code earlier as it works for your users in all the different browsers and platforms and mobile devices you support. The only way you know that is via functional testing. So if I wrote something that wasn't IE9 compliant, that would get caught in the functional tests, assuming I had a functional test for it. Okay, so I raise a pull request, I write my unit test, I write my functional test, write my source code, it passes. Then I get someone to code review it, it gets merged in, and that's what the QA job is doing. It's saying when anything is committed to master, please run my unit test, my functional test, my performance test, and then deploy to my QA environment. So here, I basically have a continuous deployment to QA. Does that make sense? And then the last one, prod, is saying at 3 p.m., please run the unit and functional tests, and if everything's okay, deploy to production. If anything, and if the build passes or fails, notify the on-call engineers and the production team as well. So this is all we essentially needed to create a continuous delivery or deployment pipeline. And doing this up front at the start of a project ensured that we had a continuous delivery pipeline throughout the entire lifetime of the product. And as we added new technologies, it's really easy to integrate. So let's say, for example, I want to add an XSS testing to my QA build. I would just create something in my grunt file and then put it in the command and raise a pull request. And my pull request build itself is now even testing the config.json because I submit a pull request to my repository, which then triggers this whole entire process. And we'll run through this. We talked about the pull request build, and you can really tell I'm passionate about that. It is my favorite feature. But what it really provided is the ability to test in isolation. Frequently, you have 100 commits go into your repository, and then a nightly build runs, and then the tests fail. Now, how do you isolate the 20 failures you had to the 100 commits that made it in? It's very tough. You have to then roll back, cherry pick, and so on, and the entire day gets wasted debugging the build and getting back to a stable state. Not if you're testing in isolation. If you're testing in isolation, you're saying you must pass through the acceptance criteria. The unit test, the functional test, the code coverage before anything even gets code reviewed or makes it into master. This also served as a developer feedback mechanism, because me being the developer, I don't want to write code that results in an outage in IE9. I wouldn't have done that if I had known my code was not IE9 compliant. So the build runs, the functional test run, it fails, gives me the feedback saying, hey, this isn't going to work in IE9. You're going to need to fix this before we move forward. Also now, since we ran the test on the pull request, the whole entire pipeline stays clean, because whatever makes it into master is essentially tested. So when the test run once more against it, we know and have high confidence that they're going to pass. And the real key of all of this is all I had to do was just say PR build and say what I wanted to happen in my PR build. And all of this happened. All the GitHub integration as well as CI integration and so forth. We talked about the pull request build. Here's the diagram. Developer submits the pull request. That triggers the build. You get the feedback. Is it safe to merge or not safe to merge? Someone code reviews it. The QA build's listening for commits into master. Once again, runs through the unit tests and other checks, and then pushes to QA. So we're continuously deploying to QA. The only thing that's not shown here is that prod build, which would get triggered at 3 p.m. and pushed to production. Anyone here doing pull request builds currently? Awesome. Awesome. Anyone running unit tests in those pull request builds, or anyone running functional tests? Awesome. I'd like to see that. Now, what all of this really meant to the developer was that I can now focus on writing source code and writing test code. I can get up and running really quickly. It doesn't require a big upfront investment of creating a pipeline. All I have to do is create a config.json. I got a pipeline, start developing source code, start writing tests. Everything's getting tested, everything's getting deployed, everyone's happy. Also, what this really provided is, I remember as a front-end developer, I would get a product manager coming to my desk at least once a week saying, is this pushed to QA? I need to demo this. Is this pushed to QA? Yeah, it's pushed to QA. We have a continuous deployment pipeline. If the tests are passing and if everyone's writing good code, it's going to QA. I never had to, explicitly push or build and force a push to QA of any sort. Also, I talked about how Screwdriver was a layer on top of Jenkins, and it would not only create these jobs and configure them, but it also had a front-end interface for monitoring all of this in case if you wanted to see where the jobs are at, what's happening, as well as if you needed to explicitly trigger a job. So developers themselves didn't need Jenkins knowledge or expertise. They just needed the documentation on this config.json. They would code one up, create a Screwdriver job, and get up and running. What this meant to the organization was less change-related outages, and this was critical. We needed some type of system or some type of metrics to measure. Is this really helping? Is the centralization really helping? Did Screwdriver really help us to get to continuous delivery? Did it help us improve quality and improve efficiency? So we needed some way to measure this. And as I talked about earlier, the change-related outages was the primary metric. If we could lower the number of change-related outages and up the number of pushes to production, that was a success in our book. And the number of change-related outages started lessening and decreasing and kept on decreasing. Now, this might sound crazy. The more you push to production, the less change-related outages you have. But if you have the proper testing in place, as well as the proper checks, and you're only working on small iterative features that you can push frequently to production, that's much safer than working on a big feature and a lot of commits going to production. So if we can push a day's worth of changes or even one change at a time, that's where we're going to win. Introduce the least amount of change to the system frequently, and obviously have the tests in place for that in case anything regresses. And really, what it came down to is tests were critical. Tests were the only thing that can stop the pipeline and can stop the production push. So anytime we had a production problem, we put a test back in there to make sure that same problem wouldn't happen again. And all of this was automated, as we talked about as well. Really, in the end, we had higher quality products since we were able to get out more code, more bug fixes, and more features. I remember when I was triaging bugs at the beginning of my Yahoo career, I would find the same bug over and over and over again reported to me. This was because we just didn't push that often. We'd push only once a month. And if something went wrong in that release cycle, we'd group that in the next release. And we just talked about if we push a large amount of code to production, that's a large amount of things that can go wrong. And that's exactly what was happening. And that's why we were having those change-related outages. So as we perfected this process, we were able to get more bug fixes out there, get more new features out there, as well as get feedback from our users regarding, hey, this feature is not useful. Oh, this feature needs this and this, or it's lacking this. And essentially, we were able to feed that back into product, get that to engineering, get that through the pipeline every day, and keep on improving. Also, I mean, what engineer doesn't like working on a product that has a continuous delivery or deployment pipeline? I don't know of any, or all engineers would love to do that. They don't want to focus on the build stuff and figure out releases and so on. They want to write source code and concentrate on that source code. They want to write test code, testing their source code. Now, we talked a lot about all the good stuff, screwdriver and centralization and DPS and all of that did. But really, there was a large amount of culture change involved here. Before, when there was a problem with our builds or our build slave, I'd just go in, SSH into there, check it out, and fix it. Right? Simple. Now, whether you can argue whether that's best practices or not. It's probably not best practices. But I couldn't do that anymore with the centralized structure. I didn't have access to all the Jenkins infrastructures and systems. I had to go through this config.json, check it in, and then see what happened. Now, if I needed some type of technology or some type of tool whitelisted, I had to go through the DPS team. So this was kind of a complication and challenge in that I couldn't do the things that I was used to doing, and I didn't have control over the things I used to have control over. But it was a blessing, because once I got this process perfected, I was able to focus on that source code and test code. Another part was what was common sense for the DPS team in setting up a pipeline and using Screwdriver was not common sense to the Yahoo Mail team or any of the other properties. And Yahoo Mail was actually the first bigger property to onboard onto Screwdriver and get using it. And we actually even had a Screwdriver engineer that was assigned to us. And a lot of questions that we asked him, he realized this is just a lack of documentation. So he worked on the documentation, explained how to use the config.json properly, what's happening under the hood in Screwdriver, as well as why we centralize. Why did we do all of this? Because some build engineers and some other engineers, even including myself at some point, thought, hey, why are you taking away my Jenkins server? You know, things were relatively fine. But no, they could have gotten much better because the DPS team knew what they were doing, and they wanted to scale out CD for the entire organization and get everyone on the same page. Also, one really big piece that I didn't consider until the first time it happened is when the DPS team had an outage, or Screwdriver had an outage, or the centralized Jenkins infrastructure had an outage, everyone's pipeline was blocked. No one inside of Yahoo could push anything. So you gotta understand that this is a single point of failure. If something goes wrong, you know, everyone's gonna come complaining, saying that I can't push my build or my change to production. So just be aware of the complications and challenges and weigh them against the benefits. It has to be a time where your organization is ready to centralize. You can't just completely force it on everyone. We had initiatives in place saying, hey, we must go to the centralized Jenkins infrastructure, as well as we must migrate to Screwdriver, but we knew our organization and our teams were ready for continuous delivery. Also, you must have allocation for all of this. You can't have product development and pipeline development always going on concurrently. At some point, you need to focus more on pipeline development, get all the tools, technologies, and processes correct, and then leverage all of that to deliver quality code frequently. So, through this, what did I learn? I learned that centralization has its pros and cons. Pros being specifically, it's easy to get a pipeline up and running with minimal investments up front. And I didn't have to manage a Jenkins infrastructure and so on. And I was able to focus on the source code and test code, as I've mentioned a few times. Cons, single point of failure, as well as it involves a culture change. What engineers really wanted is an easy solution to continuous delivery. They all want a pipeline where they can make sure their changes are getting build, deployed, and tested automatically. Also, centralizing all of this, what it did is it enabled all of Yahoo, not just one team or one product. Lastly, keep track of your metrics. As I explained, the change-related outage was the metric that we conveyed up to management showing this is working and it's working well. If we could say that before, in the decentralized times, that we would have 20, or I'm just putting a number, 10 change-related outages every 6 months. Now we're only having 1 or 2. Another metric that also helped us is tracking how many change-related outages our continuous delivery pipeline avoided. Whereas previously, when everything wasn't automated, there was lots of manual intervention, and if something didn't go right and was not manually verified properly or manually triggered properly, that would cause a change-related outages. We get all this stuff into source control, get all of this stuff into builds, have all the right checks in place. We're going to avoid these change-related outages. And really, that's all I had for you guys. What I hope you got out of this is to show that, that you understand Yahoo's journey from the decentralized times to centralizing, and what benefits centralizing the Jenkins and the CI infrastructures and tools can have on your organization, as well as how important continuous delivery is, and testing and isolation, and so forth. Really want to thank you guys for your time, and now I'm going to open up for questions. Once again, thank you guys.